All right, so here we have some radicals where we're finding square roots, we're simplifying, and we also have letters in them. We have variables, right? It's not just numbers anymore. So let's take a look at the process for this. So square root of 36 xy. Now you might think to yourself, oh, 36 is a perfect square. And so you may automatically know it. But if you don't think about that, that's okay. You're just thinking of what can you multiply to get 36. So, if you have no idea, then you can go to your calculator, 36 divided by 2, 36 divided by 3. Like you could type in some different things and see what you get. But maybe 4 times 9 comes to mind, right? I know that 4 times 9 or 9 times 4 is 36. Doesn't matter which order you put it. Well, let's break that down. 4 is 2 times 2, and 9 is 3 times 3. Well, there's a perfect square because I have a pair. A pair is a perfect square. A pair of 2s is a perfect square, square root of 4. A pair of 3s, perfect square was 9, right? And so I know that 2 times 3 is going to be what I have here in terms of the number part, which is 6. And think about it. 36 is 6 times 6. That's a perfect square, right? A pair of 6s makes a perfect square. And so the square root of 36 is just 6. So either way that you thought of it, you should still get 6. Now the x and the y, let's think about that. Let me slide this over here. So underneath the square root, we still have x and y. Well, think about what that means. That means there's 1x times 1y. There's not a pair of x's. There's not a pair of y's. Therefore, in the answer, we're just going to have the square root of xy still. So it is 6 times the square root of xy is the answer to this, as the square root of 36xy. All right, let's do another, see if we can make a little more sense of this. Square root of 45a squared b. All right, well, what can we multiply to get 45? There's a couple of options. I know it ends with a 5, so think 5 times 9, right? You could do 45 divided by 5 and see that it's 9. So 5 times 9, that works. And 5 is prime. It won't divide by anything except 5 and 1, but 9 will break down into 3 times 3. There's a pair, which is a perfect square, right? So if we have a perfect square of 9, square root of 9 is 3. So I know I have a 3 on the outside, and underneath I still have this 5 because there's no pair of 5s. It's just 1 5. So it has to stay under the radical, under the square root sign. All right, and now let's think about the letter part. A squared means a times a, because there's 2 of them multiplied together, and b is just b. Well, there's a pair. So I have a pair of a's, which means I have a squared, and the square root of that is just a. And then I have this leftover b. And so my answer is 3a times the square root of 5b. That's the simplified version of the square root of 45a squared b. Okay, let's keep going. Here we have something different. Take a moment, look at it. What stands out to you? One thing that stands out to me is that we have a -3 in front of the square root. Before, we had nothing in front, which meant there was just a 1, understood 1 there, right? And so now we actually have a number in front. And so that just means that we're going to multiply -3 times whatever we get for the rest of it. So for now, I'm only focusing here on the simplifying the square root part. So think of 48. What can you multiply to get 48? Well, you could do 12 times 4. I probably would think of 6 times 8 first, but it doesn't matter. Might do 2 times 24 or 3 times 16. It's all different combinations, right? Well, 6 is 2 times 3, and 8 would be 4 times 2. The 2 doesn't break down, and the 3 doesn't, but the 4 will. That could be 2 times 2, and then there's another 2. So I want to make sure I don't lose anything as we go through, because if you lose a number, you're going to miss the answer. So 4 breaks down into 2 times 2, and then I bring down that other 2. All right, pairs are perfect squares. So I have a pair of 2's right here, but notice I have a pair of 2's on the outsides as well. So I have that pair of 2's and the other pair of 2's. I had 2 perfect squares, so I have 2 2's. And then I have this 3, the sad little 3 that does not have a partner. So 3 stays underneath the radical. All right, go back to the letters. I had m squared, which is m times m, and then n is just one n. There's just one. So I have a pair of m's. That means that that is a perfect square. So I have an m. Square root of m squared is just m. And then I have this n left over. So n stays underneath. So I'm almost to my answer. I would be finished, except that I can simplify this part. I can multiply that together. So let's do that. So -3 times 2 is -6. And -6 times 2 is -12 times m. So final answer, -12m times the square root of 3n. I want to make sure that's all underneath the radical, the square root of 3n. And 4 times 3 is 12, and it's negative. I remembered to write the negative. Yeah, so there we go. All right. I hope that that's helpful. We'll look at some more very soon.